This is Brian Putt. Today we're back here for the third session about buying a new or a used car. And today we're going to talk about generating tornado charts. So something like this will actually be a little bit more elaborate than this. In this particular problem, we have a couple of different decisions. One is to buy the new or the used car. The other is to get a mechanical review. And we have the uncertainty of what the quality of that review. We're trying to minimize the total cost. In the second video, we developed the strategy table. And it interfaced with the decision policy, whether we got information or not, the type of car, the quality of information. And then the decision policy, whether we got a review that was low, mid, or high. Today, we're going to talk about the tornado chart. So let's flip over to the model. Okay, here is the model. And what I want to do is I want to do a brief review of the strategy table. We had 6 different strategies: new, used, perfect information with a new car, perfect information, used car, new car based on the mid and high evaluations, and then imperfect, new, imperfect, used, new. And then over here we had the optimum reference. So it'd be either the new or the used, and the optimum with information. I added 2 new charts. One is the 80% confidence bands. And what I did here was to calculate the P10 of each of these alternatives and the 80% confidence by taking the percentile of the 90th less this cell, which is the P10. That gave me the 80%. I could then plot the mean and the confidence band. So what does this chart tell us? What we see is that the new has no uncertainty. We just spend $39,000. And the used has a very high uncertainty around it. There are 2 perfect alternatives. They have about the same mean, but clearly the used new has a higher uncertainty. So in that case, you really would probably go with the perfect new. When we look at imperfect, once again, the means are about the same, but the imperfect new has a lower uncertainty. Here you might go with this imperfect new rather than the imperfect used new. The other graphic you might look at is this one here, where now we've plotted the 80% confidence range versus the expected cost. And once again, here are the 2 perfects that we can never obtain. Perfect information is not available. And then we start to look at these 2 imperfects, and it becomes pretty obvious that I would rather have this one than this one. So I'm going to go once again with the imperfect new, most likely. The used version has both a higher 80% confidence and a higher cost, so you would never go with that one. Anyway, I just wanted to share that. Let's get on with our tornado chart. In generating a tornado chart, we want to make it a proper tornado chart, which means there should be typically an 80% confidence band on each of the bars. And we're going to do that by plotting on one end the P10 and the other the P90, particularly for the low, mid, and high cost. The other tornadoes can be whatever we want to use. In this case, for the probability of low repair, we'll use 45 as our base. That's our center line. And we'll do a low of 35 and a high of 55. And for the inspection quality, our base is intensive review. And we really only have one side of that, which would be the quick review. So it's important that we link these variables over to our model. So right now, PM table is the active table. So let's go link these over to the PM table. So over here, now let's say, I guess first of all, let's talk about how we're going to get that 10% and the 90%. We're going to put those variables over here where it talks about sensitivity. So we're going to come over here and say equals tornado chart This is the low, and I think I can just copy that down. Copy. All right. And so now if I went over to the tornado chart and put in, let's say, a 2, this becomes a 1. And over here in the model, you see this became a 1. And then the RAND used is going to be equal to, if this is equal to a 0, it's going to use n, which is the full random range from 0 to 1. If, on the other hand, it's not equal to 0, it's going to use whatever value I had here for sensitivity. So in this case, 0.1. And when I went over to a different case, it would be 0.9. Okay, so that's how that's going to work. So we have those variables of the tornado linked. What are we going to do for this 45? Well, over here in the model, we have a column specified for PM table tornado, but right now we're using PM table. So let's just use this extensive review. That's to be equal to the tornado extensive review. Enter. There we go. And for the probability of the low repair costs, we'll set that equal to the tornado 45. Okay. I'm going to make that not colored, no fill, because now it's not a hard-coded number. We still have a little problem here. We have a PM table. So let's set that equal to the tornado. So we're using strategy 5 in this case. And yes. Well, this is going to have to be equal to whatever the get information is for strategy 5. Well, I can get that equal to the index of get information, comma, this 5. And the type of car purchase of no information is equal to the index of the strategy table, type of car, no information, comma, model 5. So a 5 is, yes, we get information and it's used. We're going to get an extensive review. If I change my tornado, up here I specify the type of tornado I want. Maybe I don't need to do this right away, but let's see if it works. Let's put in a 1. And that takes us to a new. What happened to my model? It went to a 1. We're not going to get information. We're going to get a new. We get an extensive review. And you'll notice that these pull over to this, because this over here is an index command based on whatever PM table is active. Right now, PM table active is PM, the active PM table is PM table. So that all looks good. Let's just double check to make sure PM table is empty. I'm pretty sure it is. Here's PM table is empty. Okay, perfect. Okay, I think we're ready to do the multiple experiments. So we'll highlight this variable here. Go to SIPmath, define outputs, multiple experiments. Output name is going to be tornado. Input name is going to be ME, stands for multiple experiments. Input cell is going to be this variable here. And the values are going to be the 1 through 10. And the spark lines are going to go here. So we know what are the random variables. And we'll say OK. The one last variables we need to connect are the decision policy within the inspection. What I've done here is for each one of our PM tables, I've identified the decision policy that's active at the time. So for our PM table tornado, I've used that strategy and pulled it from the strategy table. Did that for all 3. And similarly for the strategy table, we can just go click on that because it's already been selected. Okay, so I think we're ready to generate our tornado. Here I've set it to strategy 5 and calculate our 10 cases for the P10s and the P90s, and then these two other sensitivities. So the best way to plot the tornado chart is to plot the delta from the reference. In this case, our reference line is strategy 5, 38,270. So I'm going to take this and say it's equal to this minus the reference. Hit F4, copy that across. And now we notice that the quick review is actually more costly. If I want to talk about cost, I guess we could say we're trying to minimize would be one way to do it. We'll plot the first 5 columns on one bar and the second 5 columns on the second bar. This will be the basis for the tornado chart. Now that I have these 2 bars, I need to put them together so they align. So what we'll do here is click on one of the bars, right click, format that data series, and we can set the overlap to 100%. That's the trick. We'll add some labels for the bars and move the labels to low such that they appear on the left-hand side. Then we'll add a title that indicates which strategy we're looking at. So in this chart, we're actually trying to minimize the cost. So this is the car cost. Inspection quality is higher here. That's bad. So let's put a note here that this is good down here and this is bad down here. So now we see that the inspection quality, when it's equal to a quick review, is more expensive. When the low repair cost has a high probability, the cost goes down because I'm doing a used car at that point. And when the low repair cost probability goes down, in other words, a P10, I get a higher cost because that means that there's a higher probability of the mid and the high cost, and then I use the new vehicle at 39,000. These are more traditional, where here's the high cost, here's the low cost. The low cost distribution is the most important, at least for strategy 5. So now let's try going to strategy 1 and see what, or strategy 2 and see what happens. Aha! The inspection cost, the inspection quality disappeared because with just the used vehicle we didn't do an inspection. Once again, the mid cost is the most important, and the probability of the low repair is important. And if I put in a 1, everything disappears. Probably should fix this axis down here so it doesn't move around. So strategy 2, 5, 6, and 1. There you go. Okay, in the next video, we'll talk about doing some sensitivity to variables, a single variable to get some different types of curves. Thank you.